All right, I'm getting an indeterminate form over here. What do I mean by that? When x goes to 0, 2x goes to 0, and the sine of 9x goes to 0. So what I want to do is I want to write it in L'Hopital's form. And L'Hopital's form is going to be a ratio, and it would be ideal if we got 0 over 0 in that ratio, in the limit anyway. So what I want to do is rewrite this guy in an equivalent form, which means the limit, as x goes to 0. But I want to write this 2x to a power as a ratio. How would you do that? Well, let me set it to y. Take a natural log of both sides, ln y. What does that equal? Let's take a look at that. The sine of 9x would come down, all right? And then what you get though there, you get the natural log of 2x, all right? Now what do you get there? Let's write this down. You're going to get y equals e. I still don't see a quotient, by the way, but I do see a product. What's the product going to be? Sine of 9x times the natural log of 2x. And there's a variety of ways of writing this thing down as a quotient. I could write this down, and probably going to stick with this. I'm going to write down the natural log of 2x over the cosecant of 9x. All right, so that's a ratio, and I think I'm ready to do that now. So it's going to be e, and then I'm write this quotient down, natural log of 2x, and the bottom is the cosecant of 9x. All right, let me get my eraser out, erase this business over here, and start thinking about what I have now. And what I have is, the e function is nice because I can take the limit of the inside of it now. So it's going to be e, and then I write the limit down as x goes to 0 of the natural log of 2x over the cosecant of 9x. And hoping the limit's going to go smoothly. Unfortunately, what happens when you go towards 0 of the natural log, and that's a problem. And what I want to do is I want to just do it from the, let's see what we're going to do it from. I'm going to do it from the right side. I can't do it from the left side, by the way. All right? So this limit has to be revised, and I got to make sure I know that if I'm doing this over here, I really should specify this only works if x goes to 0 from the right side. And I will correct that in the notes, by the way. So let's put that down. And I could do that. What is this thing? This goes towards minus infinity. All right? Now, I want it to 0, but I'll be honest with L'Hopital's rule, if I get 0 over 0, right, that's a fine one. And the other one is just any infinity, whether it's plus or minus, doesn't matter. So anything like this, plus or minus, doesn't matter. Those two forms are good. All right, let me erase that. Let's hope I get what I get at the bottom. Well, as I go towards 0 from the right, on the cosecant of that would be plus infinity. So I'm getting that form. All right, this would be plus infinity over here. So I can use L'Hopital's rule. Let me get my eraser out, erase this over here. And I'm going to put my little equal sign down with the h on it now. And I'll put e down. I'll put the limit down. X goes to 0 from the right. And I got to be careful here. And let's take a look. The derivative of the natural log is going to be 1 over 2x times 2, which is just 1 over x. And the derivative of the cosecant is going to be, let's see, I'm going to get a 9 there, certainly, because I could chain rule. And then cotangent. It looks awful. And then cosecant. Now, I'm the kind of person that likes to rewrite things because I don't like the way that looks. So I'm not using L'Hopital's, I'm just going to rewrite it. E, I'll write down limit, x goes to 0 from the right. I'm going to put the minus sign on the outside. And I'm going to write this a little bit different. You know what? I'm going to put minus 1/9 on the outside. And you're going to get what? x tan 9x and then sine of 9x. You know what? I'm not going to do that either. What I'm going to do is bring the 9 on the inside now. Get my eraser out. There's a point to this, by the way. And let me get my, erase this 9 over here. I'm going to leave the minus on the outside, but I'm going to put the 9 over here. Now, someone says, why are you doing that? I recognize this guy. That I know that guy's limit. And that's just simply 1. That's easy to do, by the way. And the tan, as x goes to 0, would just simply be 0. So I got this over here. So what do you get? E minus the entire limit would be 0, which is simply e to the 0. What's that going to be? The number 1. All right, let's look at the key and see how we did. And I got this right over here. All right. So we're done. Thank you.